Hi everyone, welcome back to VRC Smart Edu channel, and we are with the next part of this chapter. It is part 4, Haloalkanes and Haloarenes of Chemistry, and chapter 10. This is going to be the organic chemistry. So this is the part 2 book, first chapter. So hope you have watched the previous 3 videos so that you will be clear with the concept. So let us enter into the remaining concept of this part. So, if you have not watched my previous videos, the links are provided in the description. You can go and check it out, and the link will be popping up here also. You can go and check it out. Okay, so now we are dealing with haloalkanes and haloarenes. So, in that, already we discussed about the classification, nomenclature, yes, and the various chemical reaction, that is nucleophilic substitution reaction, and the chemical reactions we have discussed. So still more we need to discuss about the elimination reaction and reaction with metals. So let us now today revise under chemical properties, elimination reaction and reaction with metals we will revise, and some physical properties and Wood's reaction. These are the things we are going to revise today. Okay, let's go on. Listen here, we are going to start with the elimination reaction. So first I am going to take the double bonded carbon compound with some X attached. Okay, so like this. Okay, so now I'm going to react it with B. Okay, boron in the presence of alcoholic KOH. What you are going to get is, listen here, this H will be going with Br outside, and this X will be going out separately, and you will get a double bonded carbon system here. How you will get is, this carbon will have the normal hydrogen, one hydrogen, and here the double bonded carbon system will be formed, and the carbon will have two hydrogens. This carbon is having two hydrogens, and this carbon is having only one hydrogen with double bond formed, plus HB will be going out, plus your X minus will be coming out. So this is your elimination reaction. Okay, I'll write it clearly. Plus X minus will be coming out. This is your elimination reaction. Clear? Right. Moving on to side-safe rule or side-save rule. This is very important. Okay. In dehydrohalogenation reaction, you know what is dehydrohalogenation, right? So hydrogen will also be removed and halogen will also be removed. Okay, preferred product is that the alkane which has the greater number of alkyl group attached to the double bonded carbon. So alkane which had the greater number of alkyl group attached to the double bonded carbon atoms. So now listen here. Listen here, I am going to have a compound. Okay, the compound is going to be CH3, CH2, CH2, CH, CH3 with Br attached. Okay, so if Br is attached to this compound, then this is going to be my beta carbon, this is going to be my alpha carbon, and this is going to be my beta carbon. Now what happens is, you can get two different types of products, okay, based on your beta carbon. Okay, based on your beta carbon, two different types of products can be formed. Okay, listen here. Your first product is going to be CH3 as it is, CH3, CH2 as it is. Okay, then here, so CH2, CH3, CH3 is there. Now what I am going to do? I am going to have CH2, CH, and I am going to remove this Br, and here I am going to attach the double bond, and I am going to write CH2. This is one way of writing, correct? This is one way of writing. And another way I can write it as CH3, CH2, CH2, CH double bond. Okay. Here CH2, so CH2 and CH3 are going to get like this. Okay. So listen here. If you see here you are getting the one compound and here you are getting the another compound. So here if you just see 1, 2, 3, 4, 5 carbon, in the 5 carbon, in the first 1, 2, so in the second position if you just see means your double bond is attached. So you can write it as pent 2 ene. Okay. And here the first carbon it is attached, so it is written as pent 1 ene. Okay, so which is going to be the major product here and which is going to be the minor product here? Pent 2-ene is going to be the major product here. Pent 1-ene is going to be the minor product here. Why? Because the greater number of alkyl groups is preferred. So greater number of alkyl groups you have here, right? So 2. So alkene, that is have greater number of alkyl groups attached to the double bonded carbon system. So here only to the double bonded carbon system greater number of alkyl groups are attached. So now major is going to be, I told, pen 2-ene and minor is going to be pen 1-ene. So major here it is going to occur 8% and minor it is going to occur 11% of chances of occurring. Clear? Now moving on to the next. Next is going to be the reaction with metals. So under reaction with metals, you have two different types of reactions. Okay, but the two reactions are very simple and easy reactions. First, you are going to take RX. Okay, that is the haloalkane. You are allowing it to react with Mg. Okay, in the presence of dry ether. In the presence of dry ether, you get RMgX. What is this RMgX is? This RMgX is nothing but the Grignard reagent. It is the Grignard reagent. Next reaction is going to be your RMgX will be there. Your R minus MgX plus Mg plus. Now what you will have is Mgx plus H2O. H2O will be divided into H plus and OH minus. You already know this, right? So when this two reacts, you will get, say, this R minus and H plus. So that RH it will go out as RH and Mgx is there. So Mgx and OH will be attached. So plus MgXOH, like that you will get. So this is going to be your alkane hydrocarbon. This is going to be your alkane hydrocarbon. Clear? So that is all about the reaction with metals. Now moving on to the physical properties. Physical properties is very important to remember. Okay. As far as chemical properties is concerned, physical properties are also equally important. So first, under the physical property, the first one is, if it is going to be under the pure state, then it will be colorless. Next, second one, if it is going to be the H nu, then it will be colored. That is kept under the sunlight. Then if you have CH3Br, CH3Cl, C2H5Br, these all the things are gas. These are gases. Okay. And when you come for the carbon, that is, this are carbon that is having only one carbon or two carbon molecules. If it is going beyond 6 to 7 carbon molecules, then it will be liquid. So based on the state of matter, how many carbons are present? 1 to 5 carbons are present, they will be under gas. 6 to 7 carbons will be liquid. And higher carbon, more carbon is there. Higher carbon is present means then it will be a solid. Higher carbons will produce solids. Clear? Right. Now let's move to the next. Next we are going to talk about the melting point and boiling point. So when you talk about the melting point and boiling point, very important points I am going to give here. Listen carefully. Let us keep the boiling point as Vp and your melting point as Mp. Okay. So your boiling point, your Vp, that is your boiling point, increases as the number of carbon atoms increases. Okay, next point. Boiling point of there is Bp of chlorides, bromides, iodides. What are these? These are the halogen atoms. Okay, they are higher than hydrocarbons. They can ask the reason why this boiling point is greater than hydrocarbons. Then you have to write the reason for it. The reason for this condition. Okay. The reason, it is because of due to greater polarity. Okay, you know what is polarity, right? Due to greater polarity, the boiling point of chlorides and bromides and iodides are greater. Okay, apart from polarity, higher molecular mass than parent hydrocarbon. So apart from parent hydrocarbon, they have higher molecular mass. So only the boiling point of chlorides, bromides and iodides are higher than the hydrocarbons. Clear? This is the reason you have to remember. Also, because of the intermolecular force of attraction, they are boiling point are higher than the normal hydrocarbons. Clear? Right. Okay. So listen here. The next point can be actually we studied this. So our next point is going to be, listen here. Okay. So the next point is going to be, so the boiling point of isometric haloalkanes. Isometric haloalkanes will decrease. Isometric haloalkanes will decrease as the branching increases. Okay. See the next point. So here I have given some order, right? Ri, Rbr, Rcl, Rf. So it is the decreasing order of the boiling point of halides. Okay. So for same alkyl group, the boiling point decreases. Boiling point of halides decreases. Okay. So in this order, it decreases in this order. This is the order you have to remember. It's a decreasing order. The reason is also important to remember here. Here you have a reason. The reason is going to be that due to the increase in the size of halogen atom, size and mass of halogen atom. So you know that while you are going down the group, the halogen atoms will increase, right? Down the group, the atoms will increase. So due to the increase in the size and mass of the atom, hydrogen in atom, what you can say? You can say that the same alkyl group, the boiling point of halides will decrease. Also, the increase in van der Waals force you can able to observe. Increase in van der Waals force. Okay. So now next point you can observe is, next point is going to be boiling point of dihaloarenes. Dihaloarenes are nearly same. Okay. So that's all here. Let's move to the next. So now we are going to start the Woods reaction. So what is Woods reaction? So Woods reaction we have already studied in our class 11 also, right? Definition of Woods reaction, everything we studied. But here now we are going to study again the Woods reaction. So first I will write the reaction and then we'll see the example of that. Okay. So be clear. Now let's start. So first I am going to write the reaction. First I am taking the haloalkane, that is Rx. Okay, it is going to be reacting with 2Na and again I am going to take the Rx, the same. Okay, in the we are going to react it in the presence of dry ether. So what is the product I am going to get is, first I am going to get this R and R is going to be combining and it's going to come out as RR. This is going to be your hydrocarbon with the presence of 2NaX you will be getting. So this is what your reaction, this is the outlet of the reaction, and instead of R you can use any other alkane you can use. So I am going to give you an example here, and with that you can keep it in your mind easily. So you can have here another example, CH3, instead of X I am taking Cl plus 2Na and again plus Cl CH3. So in the presence of dry ether, what you will get? You will get CH3 CH3 you will get plus 2NaCl you will get. So this is how you will write the Woods reaction. Clear? This is the basic idea of writing the Woods reaction. Clear? Right. So it's important. So you have to remember this. And Woods reaction is also one of the name reaction. It is also one of the name reaction. So I told already name reactions are very important. So this Woods reaction is also very important. Okay. So that's all for today's video. Thank you so much for watching this video. If you like this video, kindly like it, share and subscribe our channel and click the bell icon for notification. So when you subscribe our channel, you can receive more videos and notification of our videos. So kindly do it for sure. Then thank you and bye.